Hi, we have reached to the last lecture of limits. And in this lecture, we would like to find infinite limits where the value of the limit is positive infinity or negative infinity. And then we also want to find the limits at infinity, which means that what happens to the value of limit as x approaches to positive infinity or negative infinity. What is infinite limits? It's usually obtained when a rational function resulting in 0 in the denominator part. For example, 1 over 0. So the value of the limit will approach to positive infinity or negative infinity. Example, evaluate the limit of 1 over x squared as x approaches to 0. We must take the left and right hand limits as x approaches to 0. Now, let's say you substitute a value of x into the function 1 over x squared from negative 1 and then approaching to 0. As you approaches to 0 from the left side, you can see that the value is getting larger and larger. So what do you think the value of the limit as x approaches to 0? If this is negative 0.000000001, the value will get larger and larger. That means the value of the limit from the left side of 0 is approaching to positive infinity. Let's look at the value of the limit for function 1 over x squared as x approaches to 0 from the right side. So let's say you try to substitute in the value of 1 and then getting smaller and nearer to 0. As you can see, the value of your y is also getting larger and larger. So we conclude that the value of the limit is equal to positive infinity. Why is it positive infinity? Because both the value from the left and right side is positive and a large number. If you try to sketch your graph 1 over x squared, this is how it looks like. And as you can see, from the left side of 0, the graph is approaching to positive infinity. And also from the right side, the graph is approaching to positive infinity. That's why our final answer is the limits as x approaches to 0 of function 1 over x squared is positive infinity. First example, given f(x) equal to 1 over x minus 1, find the limit as x approaches to 1 from the right side and also from 1 on the left side. Replace your function f(x). After that, substitute your value of 1. And what you get is 1 over 0. But 1 over 0 is not the answer for your limit. So this is just an indicator, the same like as the indicators for whenever you get 0 over 0 or whenever you get infinity over infinity. This is just an indicator that states that the value of the limit will reach to infinity. But is it positive or negative? So to determine the sign for infinity, you have to check from the left and also from the right side of that value. But since we are looking at the right side of 1 now, let's check. If this is our number line, we can let any value of x as it approaches to 1 from the right side of 1. But make sure you take a value near to 1. For example, 1.1 is from the right side, but don't take 0.9 because that's from the left side of 1. Substitute the value of x into the function. We just want to check whether the sign is positive or negative. After that, 1 is positive, 1.1 minus 1 is also positive. So positive divided with positive number is just positive. So the right hand side sign is positive. So this means the final answer for this limit is positive infinity. Next, from the left side of 1, we also substitute the same function, and when we substitute in value of 1 inside, what you'll get is 1 over 0. Remember, this is just an indicator which tells us the final answer is infinity. But is it positive or negative? We have to check. So, how to check? This is 1 from the left side of 1. So, just take any number from the left side of 1. Look at your number line here. From the left side of 1, any value which is near to 1 but from the left side. For example, 0.9. You can choose 0.8 or you can also choose 0.99 as long as it is from the left side of 1 and near to value 1. Next, just substitute your value inside. So let's say this is 0.9. 0.9 minus 1 is a negative, and on top numerator is positive. So when positive divide with a negative number, the result is negative. So this means our final answer for the limit is negative infinity. Now example 2. Given the function f and find the limit as x approaches to 2 from the right side and also from 2 from the left side. Substitute your function inside, and after you place your value 2 inside, what you get is 1 over 0. Remember, this is just an indicator that tells us the final answer is infinity. But is it positive or negative? We have to check. So just choose any value from the right side of 2. You can simply draw a number line. If you have a little bit of confusion on what value should you substitute in, so from the right side of 2, this is just 2.1 or 2.01, whatever value which is near to 2 from the right side. Let's say you substitute in 2.1 into the function. So this is 1 over 2.1 minus 2 bracket squared. When you press your calculator, what you get is positive on top, below is also positive. So positive divided by positive is positive. That's why your final answer is positive infinity. Next, also substitute the function of fx into here. After that, replace your value 2 inside. So 2 minus 2 is 0. Remember, this is not the answer, it's just an indicator that tells us the final answer is infinity. But positive or negative, you have to check. Look at your number line. So from the left of 2 is just a value less than 2. For example, 1.9 or 1.99. Let's say I substitute in 1.9. So just substitute into the function 1.9 minus 2 bracket squared. On top, the numerator is positive, and now the denominator is negative value inside, but square that negative value, you still get a positive value. So the final answer is positive. This means our answer for this limit is positive infinity as well. Next example, we want to find the limit of this function as x approaches to 3 from the right side of 3. So the first step is to try to substitute the value of 3 inside the x. 3 plus 3 is equal to 6. But 3 minus 3 is equal to 0. Even though at the numerator, the value is 6 and it's not 1, but since it is divided with 0, this is an indicator that tells us the final answer would be infinity. But is it positive or negative infinity? We have to check. Draw your number line. This is 3, and we want to check 3 from the right side of 3. So what is the value nearest to 3, but from the right side? You can choose maybe 3.1. So just replace 3.1 into your function. After that, check whether it's positive or negative. At the numerator, it is positive. At the denominator, it is also positive. And the final answer is going to be a positive sign. So the limit is positive infinity. Let's look at example 3b. We want to look at negative 1 from the right side. So first step is to substitute your value of x inside. Substitute negative 1 into the x. What you'll get is 2 over 0. Remember, this is not the final answer. This is just an indicator that tells us our final answer is infinity, but is it positive or negative? So to determine the sign of the infinity, we have to check negative 1 from the right side. You can simply draw a number line. If you are confused, from the right side of negative 1, what is the value? So just choose any number bigger than negative but near to negative 1. For example, negative 0.9. Replace your x with negative 0.9 and see what are the signs. At the numerator, the sign is positive. At the denominator, the sign is negative. So positive divided with negative, you get a negative answer. This means that from the right side of negative 1, the value of limit is approaching to negative infinity. Now, after you understand the concept, try example 4. Pause the video and then check your answers after you are done. Okay, so example 4 wants you to find the limit of this function 1 over x squared minus 4 and replacing the a with the ones written in a, b, c, d. So the first one is limit as x approaches to 2 from the right side. Now, just replace the value of 2 into the x. What you get is 1 over 0. Remember, when it's 1 over 0, we know that the final answer is infinity, but is it positive or negative? Just choose a number greater than 2 because it's 2 positive from the right side. Let's say you substitute 2.1 inside, 2.1 squared minus 4 is positive. So positive divided by positive is just positive infinity. You do the same for b, but now it's from the left side, so just choose, maybe you choose a number from the left side like positive 1.9, substitute inside, what you get is negative sign, so it's negative infinity. And then for c, the value is negative 2 from the right side. So for negative 2 from the right side is a number greater than negative 2. For example, negative 1.9. Substitute negative 1.9 into the x, and what you get is a negative sign. So the answer is negative infinity. Now, example D, negative 2 from the left side. So when you substitute in negative 2 inside, you see that it is 1 over 0, which means the answer is infinity, but you have to check from the left side of negative 2, and let's say you choose a number close to negative 2, like negative 2.1. So when you substitute negative 2.1 inside, what you get is positive infinity. Now, what is limits at infinity? Limits at infinity is, for example, look at this graph, the function green. When we want to find the green function, fx, as x approaches to negative infinity, the infinity is on the left side, somewhere very far. And what is the value of the limit as x approaches to negative infinity? This is the asymptote, which is y equal to 4. So the graph will reach approaching to y equal to 4 line, but never reaches the value of 4. So the limit for this question is 4. What about this graph? Function gx. As x approaches to positive infinity, the value of y is approaching to the x-axis. And the x-axis here, the value of y, there is y equal to 0. That's why the limit is equal to 0. Let's look at example 5. Given the graph of fx equal to 2x over x minus 1, state the limit of fx as x approaches to infinity, positive, and also negative infinity. By looking at the graph, x approaching to positive infinity is to the right of x-axis. And what is the value of the function as it is approaching to positive infinity? The value of y will be 2. For limit as x approaches to negative infinity, when negative infinity is on the left side of the graph, you can see that it is approaching to the value of y equal to 2. So that's your limit value. Example 6. State the limit of fx as x approaches to positive infinity and negative infinity. Substitute the function inside, then what you get is 1 over infinity. What is 1 over infinity? If you try to press your calculator 1 over a very large number, what you get is equal to 0. Please remember this property. Any number divided with a very large number is equal to 0. Any number divided with a very small number is also equal to 0. Next, limit of 1 over x squared as x approaches to negative infinity. Substitute your negative infinity inside. What you get is negative squared would be positive. So this is just 1 over positive infinity. And the answer is 0. Remember? Now, example 7. Find the value of the limit as x approaches to positive infinity and negative infinity. Replace your function f inside. And then remember, first step is to substitute the value of x. X is positive infinity. Positive infinity plus 1. Positive infinity is a very large number. When you add 1 to it, it's still a very large positive number. So the answer is positive infinity. Next, limit of that function as it approaches to negative infinity. So negative infinity is a very small number. you add 1 to a very small number, still it is a very small number. So it is negative infinity as the answer. Now, for example 8, we want to find the limit of this function as x approaches to positive infinity and negative infinity. Replace your function, but since we have x squared plus 2x plus 1, we can simply substitute your value of infinity. Whenever you have x greater than power 1, what you have to do is factorize the highest power of x. After you factorize the power of x squared, what I want you to do is just copy the same function and then divide each of the terms with x squared, because we have factorized x squared. So what's left is just x squared in front, and simplify this. This is 1, simplify this, 2 over x, and then 1 over x squared. When you try to expand this, what you get is exactly the same function. After that, use your property of limits, split this into 2 limits. You have seen this in the examples of tutorial 4. What you have to do next is you have to use the theorem of limit as x approaches to positive or negative infinity, and the function is 1 over x power n, as n is greater than 0, so the value of the limit will equal to 0. So use that property. When you substitute in value of infinity inside, what you get here is 0. Okay, so refer to tutorial 4 video. After that, you can replace positive infinity into our x. Positive infinity squared is just positive infinity. When you multiply positive infinity with what's left here is just 1 plus 0 plus 0, so it's just 1. And the final answer is just positive infinity. But what about the next question, which is limit of fx, the same function, as x approaches to negative infinity. So since we have the same function, we still have to do the same method, split it into 2, and then use your theorem. The theorem also applies for when x approaches to negative infinity. So the value here is also 0. And then replace your negative infinity to the x squared. What you get is negative infinity squared times with 1. Negative infinity squared is just positive. So the final answer is positive infinity. Last example. Now we want to find the value of this limit as x approaches to positive infinity. The function has x more than power 1. So I prefer you to factorize the highest power. Remember, when you factorize that highest power, just copy everything else into this bracket and then divide each of the term with the factorized term, which is x power 3. So divide everything with x power 3 and then simplify. So after simplified, that is what you get, and then you can split this into 2 limits by using the property. And then remember the theorem, this value will equal to 0. Substitute the value of positive infinity into the x. Positive infinity power 3 is just positive infinity. What about as x approaches to negative infinity? You also do the same thing, and then you can just factorize x cubed. After that, simply replacing your negative infinity into the x. Negative infinity power 3, remember, a negative number, it has an odd power, the final answer will still be negative. So that's why it's negative infinity. And here, according to the theorem, the value will be 0. So 0 plus 0 minus 0 is just 0 plus 1 times negative infinity. The final answer is negative infinity. So that's all for today. Thank you.